Hey, what's up guys? I'm just making this other video about something else I was stumped on with OpenGL. So, um, I was trying to figure out how to alpha blend correctly, and I just kind of glanced over it at first, and then I realized that I was having some really weird issues with alpha. So, the wiki, I just looked at the wiki when I was using GL blend func, and it says transparency is best implemented using the blend function, GL source alpha and GL1 minus source alpha. And that's what I did right here. And that's going to basically, if you look at the Wikipedia page, Wikipedia alpha compositing, there's an equation that you're supposed to use for like when two things are overlaid like this translucently. To get it to look realistic, you should follow this equation. So the out alpha of the pixel is going to be the source alpha minus the dest times 1 minus source alpha. And you can see that's correct, but the RGB is completely differently calculated. And if the destination background is opaque, then it can be simplified to this. So that's what this is actually doing. This is assuming the destination pixel is opaque, and this is only going to work for frame buffers without rendering stuff without alpha. So I'm going to just show you how this falls apart and show you how I solved it. So here's my little setup. This is all messy right now because I'm just debugging stuff, but so I'm rendering to, this is a texture, I just have it named, and I just generate textures on the fly here and get them by their name, which is a string. And so I'm rendering to the texture FG1 foreground 1, and then I just render that straight to the frame buffer. This isn't used right now. Foreground 2 is empty, so that just doesn't do anything. But you can see I just render 2 squares to this, and then it works fine. But there's actually is transparency here, which is the edges right here are actually transparent because they're anti-alias, and this gets blended, and it is actually blended correctly because the destination pixels are opaque. That blend function, the naive one over here, this is only going to work if the destination pixel is opaque or completely transparent. If it's anything in between, it completely falls apart. So if I render to two different textures and then try to render those, you'll see it falls apart. You can see it has like a little black outline right here, and that's actually the screen behind it, and I can illustrate that here. I'm rendering to an empty texture here, rendering. So yeah, and you can see there's actually the green from the background seeping through, and that's because it just gets even more messed up the more times you try to render it, because that blend equation that gets the alpha completely wrong. So I'm rendering to this, rendering 2 quads here, and then I try to render the second quad on top of the first quad's texture, and that I can render this. Remember, we rendered this and it was fine, but that was just because it assumed the like this was just blit directly to the screen, and it ignored the alpha, because when you blit something to the screen, it doesn't take into account the alpha. So yeah, that actually completely falls apart because we're relying on the alpha to be calculated correctly. Wait, does this work? Oops. So yeah, we're relying on the alpha to be calculated correctly because we render the second quad on top of the first quad, and then that gives us the texture foreground 1. And then this would be correct. We could render this straight to the screen, and it would actually work with... Okay, it doesn't work, but you can see it's just completely messed up. The more times, it gets a little bit confusing, but the more times you render it, the alpha just completely decays, and you can see the alpha just is not being calculated correctly. And it only works if you have one layer. Okay, I know why that is. That's because the alpha is already messed up on the very first run through by the blend function. So yeah, it's pretty confusing, but so yeah, you can see why this stumped me for a bit, and I found like a few questions on Stack Overflow of people describing it a little bit, and there were people saying to use pre-multiplied alpha, and I'm just going to illustrate just how messed up the alpha gets. Here you see I render this same purple thing, and not only are the edges messed up, these work because the destination and the source of every pixel is completely opaque here, so that blends correctly, but because the alpha will be calculated correctly, but for any other case it gets completely messed up. So if we set the if we try to render it partially transparent, it just completely bleeds through the green background because this messes up this texture's alpha, and then it just gets all messed up. So basically the solution to this is you have to use pre-multiplied alpha, and that's because there's no way to describe this equation exactly using the GL blend funcs, but it's not so bad because you can just do pre-multiplied alphas, which means here are the two functions I use in the shader. When you pre-multiply it, it just means to multiply the RGB by the alpha. You leave the alpha alone, but multiply the RGB by the alpha, and then and then also make sure to use GL1 minus source alpha and GL1, but so yeah, and you can look at the equations yourself here on this alpha compositing page. It gets a little bit confusing trying to think how this GL1 minus source alpha comes with this. Obviously you can see it, that's how the alpha is calculated, but and so it's calculating the alpha correctly, but it gets a little bit confusing with just how this works. So I guess basically the one thing that's missing, you can do GL1 and GL1 minus source alpha, and but you still need to multiply each side by source alpha and dest alpha respectively. And what pre-multiplying does is just do that, and you can just simply undo it like this if you need to. And I'll show you how this works with our improved translucency resolution here. And this is actually also going to be messed up right here, you'll see. You see it's still the textures are still not correctly, has this little like weird bleeding edge thing here, and that's actually because another thing is you don't want to pre-multiply them twice. So what I did here is I just keep track of, okay, is this texture already pre-multiplied, and whenever I render to it I just set is pre-multiplied to true. Basically over here I just set whenever I'm about to render to it, I basically just pass that in so I can check right here right before I use the texture within my fragment to render to another texture here, and yeah, so this will work now because I read that you had to pre-multiply it, but and you see there's no type of weird edge right here. If I zoom in, it's completely perfect aliasing resolution there, and that looked a little weird right there. But if you zoom out, you can see it's exactly how it should be, and it's the same as if you just rendered them all on one plane with the naive resolution, or one texture with the naive alpha resolution. And yeah, so the two, that's obviously you just pre-multiply it, but two things to remember here that I didn't get right away are that one, when you blit it to the screen, it completely ignores the alpha, and that's why the naive method works slightly, because when you blit something to the screen, the alpha is already all messed up, but it just ignores it. And this means you don't have to, this works pretty well because then you don't have to undo the pre-multiplying before you blit it to the screen. So yeah, you don't have to undo the multiplying before you blit it to the screen, but you do have to, I think I forgot to mention, you do have to undo the multiplying if you, you see, I don't want to multiply twice here, and maybe your setup would be different, but I just undo the pre-multiply because I get passed in, I pass it in a RGBA color right here that isn't pre-multiplied, and this function just takes a render nameless. You can apply a color tint to it, and that's not going to be pre-multiplied, so I just, these two, I just unpre-multiply them and then multiply it by the render color mask, and then just re-pre-multiply it. But yeah, you do not, two key things that I got confused on, you do not have to unpre-multiply it before you blit it to the screen, because blitting it ignores the alpha component anyway, and pre-multiplied textures, their RGB is also already going to be like resolved with the alpha in it. And you don't want to pre-multiply it twice, because if you pre-multiply them twice, yeah, you'll get like a weird effect as well, and you'll get some similar alpha decaying effect. But yeah, that's basically it. Now I have this thing working over here. This is what I needed it for. This I was having an issue with I have these multi-sampled render buffers, so I can create these cool mask effects, but it had these like ugly black outlines. I was like, what the heck is that? Is it like the multi-sampling not working or something? But yeah, it was just because of the naive blending. So yeah, that I just wanted to make a video about that. Might start making like dev logs or something, and also maybe hopefully this will help people. So yeah, thanks for watching. Bye.